I'm only going to give you square roots, so you don't have to check. Cubic roots. And the reason is we can have negative values under cubic roots, right? So that's why negative values are okay, but we can't have negative values under square roots, which is why we have to check our square root answers. Okay? So, if possible, isolate the root as much as possible. In other words, if you've got more than one square root going, put a square root on each side of the equal sign. Don't have them on the same side. If there's more than one square root in the problem, don't have them on the same side of the equal sign. So in other words, if I give you a problem like this, square root of x plus square root of x minus 1 equals 0. Rachel, I don't want them on the same side. I want you to rewrite it as square roots of x is equal to negative square roots of x minus 1. Put them on opposite sides. No, the sign that changes is the sign of the term. You can't pull a negative sign inside a square root. Okay. 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 Yep. Okay, so I'm going to erase this part for right now. It'll be on the voice record if you need to look back at it. So, isolate my root. My root is isolated. I have nothing on the same side as a cubic root. All right. So how do I remove a cubic root? I cube the side, right? The entire side. So I'm going to cube this side, and I'm going to cube this side. So that tells me that 2x plus 7 now is equal to 27, because that's what 3 cubed is. And now we solve. 2x is equal to 20, so x is equal to? It's a cubic root. Do I have to check this problem or this answer? No. So if you were going to check it, yes, just because you have some time and you want to make sure you didn't do a silly algebra error, you'd put under the cubic root 2 times 10 plus 7. Does that equal 3? That's the cubic root of 27, which 3 then is equal to 3, and it checks. Okay? X. All right, so on number 2, I have a square root, correct? The root is isolated. So I'm going to square the left side. So I square the right side, not the individual terms, but the whole side. That makes this 7x plus 15. But what does that make x plus 1 quantity squared? And how did I get that? Because it's x plus 1 times x plus 1. So we're never pulling in a squared exponent when I'm adding in that parenthesis. So that means now we're going to solve. So to solve, everything has to go onto the same side of the equal sign. So I'll move it to the right because my x squared is positive there. That leaves me with x squared minus 5x minus 14 equals 0, because I'm moving the 15 to the right by subtracting it, and I'm moving the 7x to the right by subtracting it. And then I would factor. X minus 7, x plus 2 equals 0, x is equal to 7 or negative 2. Now the funny thing about square roots is sometimes both solutions work, sometimes none of them work, and sometimes only one works. And that's why we have to check them. So we're going to check x equals 7. And you have to show this work that you're checking it. You can't just do it in your head. Okay? So I'm going to put in here, I'm going to say 7 times 7 plus 15. Does that equal 7 plus 1? Well, it's under the square root in the original problem. So the square root of 64 is 8, and 7 plus 1 is? So I know that this one works. This is a good answer. because the left side equals the right in my check. If it doesn't check, Meg, I would have gotten something like 2 is equal to 8 when I checked it. So now I need to check x equals negative 2. And so under the square root, I'm going to have 7 times negative 2 plus 15. Does that equal negative 2 plus 1? All I'm doing is plugging in my negative 2, correct, for my x? Are you with me? So this is going to give me the square root of 1. Does that equal negative 1? What's the square root of 1? 1. Does 1 equal negative 1? No. So therefore, negative 2 is really not an answer. It's an extraneous root. Okay, so the only solution that works is 7. And you need to indicate that really clearly, that the only solution, while you get 2 answers when you solve, that of the solved answers, only 7 is the one that works. Sure. Just do what I did. Just cross out the one that doesn't work by showing me the check that it doesn't work, right? Okay, so you try this one. You try under the root, 10x plus 9 is equal to x plus 3. And so you're going to have to think, as you're working this problem out, you're going to have to think back, how would you factor something like that? And what's the first question you always ask yourself when you're factoring? Can you pull anything out? Can't forget your bag of tricks. So what can you pull out? And that leaves you with? So what are your solutions? And 0, right? You get 0 from the x that you factored out. You get 4 because of what's in parentheses. Does that make sense? Well, sure, because you pulled out an x, right? Don't you set x equal to 0 and x minus 4 equal to 0? And so now we check it. So you check x equals 0, and you have to check x equals 4. Because when I plug in the value of 4, and for the x here, I get 40 plus 9. Right, and what am I left with? What's 10 times 0? Does that make sense? Because I can have negative values under a cubic root, but I can't have negative values under a square root. And so sometimes we do get negative values, and then that eliminates a solution. This lesson, yeah. Okay, so here, the next one of the first things I said is that if more than one square root appears, that you want them on opposite sides of the equal sign. So I'm good on the first one. And if I want to eliminate the square root, I simply square both sides, which leaves me with what on the left and what on the right. So this is a nice, pretty easy problem, right? Solving gives me that x equals 2, and yes, because it's a square root, I have to check. So my check will say square root of 4 plus, not in my book, x to the here and the 5 to the right. 7 minus 5 is 2. Okay. And so that's going to equal 2 plus 7, so root 9 equals root 9, and I'm good. Are we in agreement? Egg? No, it'd be x minus 2 equals 0. And then you have to move the 2 back over because you have to solve for x. Like if I move this 7 to the left, isn't it negative 2? I mean, I can't do x minus 2 equals 0. That doesn't solve for x. What does x still equal?
Either way, you'd have to divide it by 3 or 4. If you move,
I'm not dividing by anything. I haven't solved for x.
I was thinking if you move the left side over to the right side, then it would be negative.
Then you'd have negative x plus 2 equals 0. Okay? I convinced you? Okay, that's all right. Okay, so then the next one. What's going to make this one messy, long, and not fun is the fact that, yes, I have square roots on both sides, but I also have that minus 2 going on there. So what we do, remember, is we have to square not terms, but we square sides. So I square this side, and then I square this side. And remember, we don't distribute squares when we're adding and subtracting, which we are on the left side. So this one says square roots of x plus 6 minus 2 times what? Square roots of my x plus 6, no, minus 2. Because aren't we repeating what's on the left side twice? But on the right side, it becomes a pretty value of x minus 2. So we have to FOIL. What's square roots of x plus 6 times square roots of x plus 6? That becomes nice. We're foiling. First inner, outer left. Because the square root of x plus 6 times the square root of x plus 6 is the square root of x plus 6 quantity squared. And so the square root of something squared is just what's underneath there. Right? Now, when I take the square root of x plus 6 times the negative 2, what do I get now? Root x plus 6, right? And then I do to the negative 2, I go to the square root of x plus 6, and I get again what? Square root of x plus 6. And then when I take the negative 2 to the negative 2, what do I get? And now I still bring down that x minus 2. So this is a multiple step problem where we're just kind of doing the same thing over and over again. We're going to combine our like terms on the left. The plus 6 and the plus 4 gives me x plus 10. Would you agree? And the negative 2 root x plus 6 and the negative 2 root x plus 6, we learned from the previous section, gives me what? Negative 4 root x plus 6. Now that still equals x minus 2. Now the very first thing that I told you to do when doing this problem is to isolate the root. So is my root isolated? So now that means everything that's not with the root can go to the right side. So I'm going to subtract the x and subtract the 10. And what's nice in this problem is while I get negative 4 root x plus 6, the x's drop out on the right. Would you agree? And I'm just left with negative 12. I can go one of two ways. Because I can get rid of this negative 4 by doing what to both sides? Divide by negative 4. Because this comes out evenly on the right, I'm going to do it. But if it didn't, I would have left that negative 4 there on the left side. Okay? So now I get root x plus 6 is equal to what? And I still need to solve for x. What do? Square both sides. And so x plus 6 is equal to, which means x is. So after all of this work, I simply got that x is 3. But what do I need to do? So we go back and we say, well, we're going to check this problem. X minus, or plus 6 minus 2 has to equal square root of x minus 2. And we're going to insert the 3. Square root of 9 minus 2, which is 3 minus 2, which is 1. Does that equal square roots of 3 minus 2, which is square roots of 1? Sure does. So this is an okay solution. Sometimes it doesn't. So this was my original problem up here. Yeah, now this, I went back up to here and checked it now. So let's say then I took here, negative 4 root, what, x plus 6 equals what? And let's say I didn't want to lose that. If I would have squared this, I would have gotten 16 times x plus 6 and 144 here, which would have gotten me down to the same value of x equals 3. Sometimes I can't divide this coefficient into this term. And if that's the case, I don't want to deal with fractions. So let's leave it on the side and make sure that we remember to square it. No, I would just divide by 16. So x plus 6 is equal to 9, and x will still equal 3. Okay? Okay, here, isolate the variable, get the exponent equal to 1, and solve for the variable. So now what we have are exponents that are fractions. So, you know, I'm saying 3 and the square root of x to the third. But we can work with this as if they were just fractional roots. All right? Isolate the variable. This 3 needs to move because it's not associated with the variable, is it? It's not saying this, which means the exponent is attached to both, correct? That's not what I'm saying. So how do I move that 3? So that means x to the 3/2 is equal to 375 over 3, which is 125. Now the next thing that I said is get the exponent equal to 1, positive 1. So what would I raise this side to so that I get 1? Nope. 2/3. Right? If I take this to the 2/3, then I take this to the 2/3. Right. So this is going to be x to the 6/6, which is really just x to the first. And then I'm taking the cubic root of 125 and squaring it, because that's what the 2/3 means, correct? So that means x is equal to 25. Cubic root of 125 is 5, and then we square it. No, these ones you don't have to check. All right. Notice the next one. The 4/3 is for everything inside there. So I can't move anything, and I'm certainly not going to distribute that 4/3. Would you agree? Because I'm subtracting in that term. So I got to move the 4/3. How do I move the 4/3? Take it to the what power? 3/4. And so I got x minus 4 is equal to, well, 81 to the 3/4 means the 4th root of 81, which is, nope. That's the final answer. The 4th root of 81 is 3, and 3 cubed is 27. So x minus 4 is 27, so x is 31. These ones with the exponents, fractional exponents, you don't have to check them.